Hey, this is Mrs. Taylor, and I just want to use this video to kind of review what we went over last week. There's a little bit of a blur with the Spirit Week activity, so I just want to catch you up, kind of give you the meat and potatoes of everything we did so that you're ready to move on. So what we did was we learned about arithmetic and geometric sequences, and the bottom line was arithmetic sequences are sequences of numbers that are generated by adding the same number to each term. Geometric were sequences where you had a sequence of numbers that was generated by multiplying the same number every time. And so we learned what those were, how to identify them, how to extend the sequence, so give me the next three terms of this sequence. And then at some point by the end of the week, we were kind of working on formalizing our pattern into a formula equation type thing. So to start with, some of our work, we learned how to identify a sequence as arithmetic or geometric. So that's what this sample problem is. It asks you to determine the common difference or common ratio, and we learned that the common difference goes with arithmetic because that is the number you are adding each time. And it's a little deceiving because you think, oh, it says difference, that means subtract. Well, you can think of it this way. I can find the common difference by subtracting, but when I'm generating my numbers, I add. And then geometric sequences have a common ratio. So that's the number that you multiply by. But to find it, you divide. So ratios, think ratio means division. Well, to generate the sequence, we would do the opposite, which is to multiply. So if I want to figure out if a sequence is arithmetic or geometric, one big clue is if the sequence is getting really, really big really quickly or really, really small really quickly. Probably geometric. So if you look, A is kind of slowly changing, but B goes from 200 to 0.022. That's a huge change. So that's probably geometric. Another way we can tell is by testing. So if I think that A is arithmetic, I can take the second term, subtract the first term, and that would give me the difference. So the first term was negative 8, and subtract that from negative 6, and something's not right with this calculator. Hold on. Clear that out. So we have a negative 8. Alright, sorry about that. I'm not used to using the calculator on the computer like this. So we want the second term, negative 8. So negative 8. And subtract the first term, so minus negative 6. And the result of that should be the common difference. So if this was arithmetic, if I added negative 2 to each term, I should get the next term. So negative 6 plus negative 2 is negative 8. Negative 8 plus negative 2 is negative 10. Negative 10 plus negative 2 is negative 12. Negative 12 plus negative 2 is negative 14. So they are adding negative 2 each time, which makes it arithmetic. And since it's arithmetic, it has a common difference, and that common difference was the number that I'm adding each time. It's the number I got from taking the second term, subtracting the first one. So this first sequence is arithmetic, and the common difference is negative 2. Now, B is looking like it's geometric because it changes so quickly. But if I just wanted to check, I could take the second term, subtract the first term. If I'm thinking it's arithmetic, then that means I would be adding a negative 180 each time. Well, 20 plus negative 180 does not equal 2. So I'm not maintaining that common difference, which makes it not arithmetic. So to test to see if it's geometric, instead of taking the second term and subtracting the first term, I take the second term and divide it by the first term. So that would be 20 divided by 200. And that would be the common ratio. So that would be the number I would be multiplying by. And if I don't feel very confident with decimals, I can use my calculator. So 200 times 0.1 does, hold on, 200 times 0.1, okay, does equal 20. I'll multiply that by 0.1, and I do get 2 times 0.1, give me 0.2, times 0.1 would give me 0.02, so now I can see that this is geometric because I'm multiplying by 0.1 every time. And that would be my common ratio, 0.1. So this would be geometric, and then my common ratio would be 0.1. Or in decimal form, that would be 1/10. So that is where we started. After we learned what arithmetic sequences were and what geometric sequences were, we learned about how to identify the common difference and common ratio. Now, from there, because we know that vocabulary, we can do an activity like this, where they tell me, write the first 4 terms of each sequence. They identify the first one as arithmetic, which means I'm going to generate it by adding the same number. It says a common difference of 7, so that tells me that I'm going to add 7 each time to generate each new term. And then they tell me that the first term is -12, so that's what I start with. So my first term is -12, and then to get the next term, my common difference is 7. So I add 7 to -12, and if you don't want to do that in your head, that's fine. So 12, make it negative, plus 7 would be -5. And then, and then I would add 5 again, which would be 2. Add 7 again, which would be 2. And then add 7 again, and now I'm up to 4 terms. 1, 2, 3, 4. Now, a geometric sequence means I'm multiplying, and they tell me the common ratio is 0.1. So that's the number I will multiply by. And the first term is 100. So the first term is 100, and to get the next term, I would take that 100 and multiply it by the common ratio, which is 0.1. So 10. That would be my next term. And we've seen this pattern because it's the one we just looked at. We know the decimal is just moving along to the left 1 unit each time. So the next one would be 1. And then multiply that times 0.1, and I get 0.1. So those are the first 4 terms of that sequence. It's a geometric sequence with a common ratio of 0.1 and a first term of 100. So then we moved on to a set of worksheets that look like this. On one side it said 3.6. These are from your textbook. Chapter 3, Section 6 was arithmetic sequences. And then on the back of that sheet was 9.1, Chapter 9, Section 1 out of your textbook for geometric sequences. So you should have seen this graphic organizer on the back. And the purpose of giving you these was for you to see the formula. So instead of having to extend out a sequence, we can clearly define the pattern with this formula, and then I don't have to write out 25 numbers to get the 25th term. It's a shortcut. So I want to show you how that works. In class I walked you through what each of these things meant, so just in case you weren't there or you didn't get to that in class, I'll do it in the video. So A sub n is your general term. So it's any term in your sequence. We want to represent that symbolically because we want to talk about it generally, and that's the way we show it, is a sub n. So any term in your sequence can be used, or this symbol can be used to talk about that. So we'll say that's the general term of the sequence. Now, a sub 1 is your first term. So that little n, that subscript of that n, turned into a 1 to represent the first term. 1 represents the first. So that n actually represents what number term we're referring to. So n is the term number. You could also call that an index. Kind of tells you what term you're on. So it's an index. And then D stands for your common difference. Now the reason those are important is because if you know what each of those mean, you can use this formula really easily because you just plug in the values for those things, evaluate, and you have your answer. So let's look at the examples that were at the bottom of the worksheet. Find the indicated term of each arithmetic sequence using the formula given above. So here's the formula, and they want the 25th term. Well, I could continue this sequence, figure out the common difference, add that over and over again till I get to the 25th term, or I could just use the formula as a shortcut. So the formula says a sub n equals. So any term would equal the first term, a sub 1. So the first term here is negative 14 plus parentheses n minus 1. N is the term number. So if it's the 25th term I'm looking for, then the term number is 25. Minus 1. That's a formula that doesn't change. It's always minus 1. And then D stands for the common difference. So I would take the common difference and multiply it out here. We'll have to figure out the common difference. Well, remember in the previous slide, we were reminded that the common difference can be found by taking the second term and subtracting the first. So the second term is a negative 8, subtracting the first term, which would be a negative 14, and that tells me the common difference is 6. So that is the number that I would plug in for the D in the formula. Now, the reason we can just jump to, finding that common difference, just taking that second term and subtracting the first, is because they told us in the directions it was arithmetic. I don't have to check to see if it is because they told me it was. Alright, so if I want the 25th term, I plug in this information, substitute it in, which I did, and then I evaluate to find the actual term. Evaluate means use the order of operations. So parentheses first, 25 minus 1 would be 24. And then I would multiply, so 24 times 6. That's next in the order of operations, 144. And then add. So add to that negative 14. And I get 130, which would be my 5th term. Or excuse me, 25th term. So that is how I would use the formula to have a shortcut. So I could do it again with number 6, 18th term. That means that the n would be 18. Common difference, take the second term, subtract the first. 120 minus 122. If I don't want to do that in my head, I can quickly type that in my calculator. It's negative 2. So then I take the first term of 122 plus the n, which is 18, minus 1, times the common difference we just found is negative 2. So 18 minus 1, that'd be 17. 17 times negative 2 is negative 34. Add that to 122, and I have my term, 88. 18th term. So once you get used to the notation, what all these symbols mean, it's very quick. Now, you can do the same thing with geometric, but of course the formula is going to be different. Geometric sequences are exponential in behavior. So what that means is part of the formula has this little, and we call it sometimes a superscript, but in math it's called an exponent. And so it's a little bit different, but it's kind of the same. There's still a sub n, there's still a sub 1, and there's still an n. So I still have a general term, I still have the first term, and I still have the term number. What's different here is that r, and that r, instead of common difference, stands for common ratio. So, same idea, just in the context of geometric sequences instead of arithmetic sequences. So if I wanted to find the 8th term in this geometric sequence, again, that's not that big of a number, but if you can get there quickly instead of having to generate the next 4 terms to get there, you might as well use the shortcut. So we need the first term, that's here, and the first term of this sequence is a 5. And then from there, I need the common ratio. And if I don't know the common ratio, sorry, I forgot that I need to put parentheses around everything I substitute. If I don't know the common ratio, I can find it like we did in that first slide, where I take the second term, -10, and divide it by the first term, a -2. So that tells me my common ratio is -2. So my common ratio is -2, and close those parentheses. And then, sorry, my computer doesn't want to cooperate. I need the n, the term number, which would be 8. And this is an exponent, so it's up top. And it would be 8 minus 1, so that would be 8 minus 1 up here in the exponent's place. Or you may have, like if you're using a Word document, you may call this a superscript. But either way, it's an exponent. So what that means when we evaluate, and that means order of operations, you have parentheses and then you have exponents. If you look at the exponent, it has parentheses in itself. So you do what's in the parentheses first, and then you evaluate the exponent. So 8 minus 1 would be 7. Then we evaluate the exponent. So I would take -2 and raise it to the 7th power. So what that would look like is I would have parentheses, -2, close the parentheses, and an exponent of 7. So that means that I do -2 times -2 times -2 times negative, over and over and over again 7 times. And it gives me -128. And then I multiply it by 5, because multiplying comes after exponents in the order of operations. So times 5. -640. So that would be my 8th term in this sequence, -640. So that was a really quick recap of what we've covered this week. And again, it was a little crazy because of Spirit Week, and that's totally fine. But now you have a video to catch up and then to review, so that we're all on the same page when we start later this week to move on.